Hi everyone. This is going to be a practical example of how to create a C# application using clean architecture and a little bit of domain-driven design. The application is going to be a crypto market analyzer that gives suggestions on which coins are likely to be profitable. I have a whole video introducing what this little algorithm will be doing, and you can check it out. You can check out the introduction over here. Now getting into the code. In this first part, I will have a module that connects to a crypto markets API, such as CoinMarketCap. This will be its own bounded context, and if later on the number of projects gets too large for one Visual Studio solution, this one bounded context can be moved to its own separate solution. Typically, I use solution folders and prefix my bounded contexts with bctx underscore, and this one will be market data's API. So this bounded context has one focus, which is just simply connecting to APIs. There won't be any database, so our project structure is going to be relatively simple. The core folder is where abstractions are declared, and this project, I define high-level API contract that will be a facade and a data model. We start with this high-level abstraction, so we are not tied to one price provider. So we're not tied to CoinGecko or CoinMarketCap. And this project is our own domain. We have full control over the shape of the data, which is actually quite useful. The price tracker facade interface has only one method, which is get latest market prices. Any concrete implementation will have to simply just implement this one method. Now, let's just do this one concrete implementation, which will be CoinMarketCap. I create two folders, and one for testing, and the other one will just contain all the main projects. Once I have a project, it's mostly about organizing related functionality in folders. The pattern I always apply when using third-party API is to think of any code that directly calls the concrete implementation as native. For example, looking at the models folder, there will be objects that map to the JSON response, and there could be a lot of them for the different API endpoints. So native is going to be the response that comes directly from, say, CoinGecko or CoinMarketCap. Typically, most APIs have some documentation and a quick start guide that lists all the endpoints and the JSON data contracts. In this file, all I have are objects that have been or will be deserialized from JSON. Looking at the implementation folder, there is native. This contains logic for calling endpoints. Facade converts this native or specific API to our domain specification. It converts the deserialized JSON and does some mapping either using the automapper library or manually. Just a reminder, we have designed the domain data contract in core and we have full control over its shape. By having this facade, the implementation is loosely coupled. It's coded against an abstraction, and switching from CoinMarketCap to another service should be easy. For any other concrete implementation, it's just a matter of using this simple template. And that's the facade done. So now we need a way to test that we can get a response. This is provided the authentication has been set up correctly. Let's create a test project. This will be an integration test project. Technically speaking, there won't be any proper or formal tests. It's just for us to make a call to the API. Let's use the facade to get the latest market data and only 500 coins. And here's the data. Comes from the API, and the facade converted the native API response to a domain contract. What we are going to do with this data in the next sections is to feed it into some logic to get a score for picking a trade. Calling an API is good enough to show a bounded context, and it still took a number of projects to get to this simple milestone. But keeping in mind that systems typically get large and need more projects as the more features are added and the solution is growing. And over time, the solution can get a little bit bloated. But this bounded context, despite being relatively simple, can live on its own. It can be its own NuGet package, could have its own Visual Studio solution, or maybe become a microservice. Or we can just keep adding more bounded context to this same solution. And that is all for this section. Next up, I will create another bounded context that makes use of this data and apply some logic in picking trades.